Hi, I'm Daniel from Ratings.com. In this video, we'll go over the newest test bench version 1.2, which has been updated for 2018 reviews. We will briefly describe the new tests that have been added, changes that have been made to the scoring and weighting system, and how it affects TV scores and our recommendations. With each test bench update, we have hundreds of ideas for changes. A lot of these ideas come from your suggestions and other improvements that we identify. Unfortunately, we've got limited resources and can't include everything, so we have to prioritize. You can see the full changelog in the description below. We will now look over our review of the Sony X900E to see these changes. The first change you'll notice is we've added the subtypes such as VA or IPS to the top of the review, so it is faster to see the underlying panel technology, which provides the first indication of a TV's performance. The bulk of the tests are unchanged until we get to the reflections test. Instead of the bright room photo with the TV on, we've replaced it with photos with the TV off, with the same average room and bright room conditions as before. This is to make it easier to see and compare the reflection performance. The total reflections and indirect reflections are new measurements performed with a sampling sphere, which provides a uniform surround light source. The first number is the total reflections from all angles and is the most important number for an average or bright room. Lower values are better. For indirect reflections, the specular or mirror-like reflections are blocked. The percentage of light reflected is then important when the overall room is light, without lamps or windows shining directly on the TV. Higher indirect reflections result in a raised black level when viewing dark scenes in an average or bright room. Now, in both the pre-calibration and post-calibration boxes, we have included the color temperature measurement before and after calibration. This is another metric to see how close the TV performs to the standard 6500 Kelvin that movies are mastered at. The color gamut numbers have all been updated. This was necessary due to a bug in the version of Calman software we were using, which produced incorrect results. We now use our own software. The gradient test has been updated completely to measure gradient performance objectively. A sequence of 4,096 points are evaluated, one for each 10-bit code word in red, green, blue, and gray. Using this data, we then use the D2000 color difference metric to identify the perceivable difference between successive points. Large differences create noticeable color banding in gradients such as skies. The standard deviation of these color differences provides an indication of the magnitude of banding, so lower numbers for red, green, blue, and gray standard deviations is best. The scoring for our temporary image retention test has been reconfigured to better align with perception. In this case, the weighting of the image retention after 0 minutes has been increased significantly as it is the most noticeable. We've added a box for permanent burn-in risk. This is so we can inform readers of TVs which may be more susceptible to burn-in when exposed to long periods of static content, for example with PC use or 24-hour news channels which display a continuous ticker. This is informed by our ongoing long-term burn-in test, which you can find a link to in the description below. We have upgraded our pixel photo method to produce clearer macro images. The motion section has undergone some significant changes. First, the motion blur box has been renamed to response time to better show that it is only one aspect of motion blur. The old backlight measurements have been split into a flicker-free box, which focuses on motion smoothness as a result of a DC or constant backlight, and a black frame insertion box, which is useful for those who enjoy the clearest image possible by flickering the backlight to reduce persistence blur. This should make it more easy to identify the backlight behavior, which suits different usages and preferences. A new test has been added for stutter. On TVs with a very fast response time, there is no blur to smooth the transition between frames, which produces a jarring image, especially for wide panning shots in movies and other low frame rate content. In the 24p Giada box, a new test has been added for Giada in native apps. You can learn more about Giada in the video which is linked below. A new test has also been added for variable refresh rate support, as it is now included in the HDMI 2.1 specification. This will be beneficial for gaming on the Xbox One X or using the TV to game on a PC. In the input lag box, we've added new tests for the input lag with a 4K 120Hz signal and for variable refresh rates. The latter will be useful for when the Xbox One X and new TVs support variable refresh rates to reduce screen tearing. In the supported resolutions box, we've added tests for 1440p and 4K 120Hz signals. We've also added tests for hybrid log gamma HDR and Wi-Fi frequency support at 2.4 GHz and at 5 GHz. The remainder of the review, such as the sound and smart features, remains the same. Overall, this doesn't affect our recommendations, but does help to evaluate more aspects of a TV's performance and allows you to identify more of the tests that you care about. So that's it. Let us know what you think about these changes. If you want us to make an in-depth video into how we test, then let us know in the comments below. If you like this video, subscribe to our channel or become a contributor. Also, we're currently hiring at our offices in Montreal for various positions, so if you want to help people find the best product for their needs, have a look at the careers page on our website. Thank you for watching, and see you next time.